Food from wood. This is the name of a scientific research project of the Zurich University for Applied Sciences in Wädenswil near Zurich, where we would like to find out whether we can reorganize the decomposing process of wood-based plant material so that we can produce food for humans with it. And it's meant to do that in mostly two stages. First, that we inoculate wood with mycelium of edible mushrooms, and after the mushrooms have eaten up their part of the wood-based material, we present the rest of the material to edible insects. And at the end of the process, we can find pre-pelletized excremental pellets of the insect that can be used as a good gardening soil. Yes, if we could eat the raw wood, that would be very good, because all of the problems with food in this world and hunger would be solved immediately. Wood is the most abundantly produced material on the whole world. It's estimated that all the plants together produce each year 28 billion, European billion, tons of wood. If we would break it down to how much it is for each human living on this planet, it would be around 3,000 tons of wood for each citizen of this planet Earth. 3,000 tons. That's around 1 billion liter oil. That's the amount of energy that the plants collect from the sun and store it in the chemical form of cellulose, lignin, let's call it just simply wood. Yeah, it would be nice if we could use this energy inside of this wood for our own well-being. I mean, around 500 grams of this beech wood would cover all the needs we have for the energy intake for one day. It has around 2,000 calories. If we compare it to a normal bread, it's double the energy of this 500 gram bread. So we thought, let's think about how we can produce in a sustainable, resource-friendly, climate-friendly way, and most efficiently food from the energy that is stored inside of this wood. And we just do it in these two processes with mushrooms edibles and with edible insects. First, the inoculation of a normal piece of massive wood is very easy. You just drill some holes into the wood, put some dowels, wooden dowels, into the holes. The dowels, they are already inoculated with the mycelium of a mushroom, of an edible mushroom. Now we have to give them some time to grow through the whole block of wood. And then, if we have inoculated this pile of beech wood, we have to wait until we can put them into a garden. Like you see here, it's in the park garden of the Zurich University in Wädenswil. Some oyster mushrooms you can see here. This is the place where people go to see what we can do with mushrooms. There's another example of a restaurant near Zurich. Here you can see it. It's also the oyster mushroom just growing on the big wood pieces that have been digged into the gardening soil. It's a very easy way to produce this kind of mushrooms. They grow abundantly. Around 30% of the weight of the fresh wood you can harvest in the form of these mushrooms. Here's a Pleurotus pulmonarius. This is one of the most simple of all the oyster mushrooms that we know until now can be grown not only in Europe, in temperate regions, but also in tropical climates, like in Africa. There are a lot of projects that deal with this Pleurotus pulmonaris that loves also warm temperatures. Now then, after the mushrooms, after 3 to 4 years, have eaten up all the lignin inside of this wood piece, only the cellulose is left over, so that's what makes them shine a little whitish, and that's why it's called white rotten wood. Half of the weight of the wood is gone, it's eaten up by the mushroom. What do we do now with this? So if we look into the nature, we see that first arrive the stag beetles. And I show you one of these stag beetles. No, not one, it's the stag beetle. It's a beautiful, wonderful, nice and big stag beetle, Vulcanus cervus cervus. You can not see it very often in Europe because it only is flying around at dawn. Females you hardly see because as soon as they have made it, they dig into the soil and lay their eggs near hidden white rotten pieces under the surface of the soil. But this beautiful male here is also part of a research project about the life cycle of Vulcanus cervus here in Switzerland. So when stag beetles eat up this white rotten wood, the larvae dig into the substrate. That's what you can see in the next video here. When we open a piece of wood where stag beetle larvae are in, we can see things like this. Here you can see the whole material is shredded, and inside a little oval-shaped chamber, here is a larva that prepares for pupation. And in the next picture you see the adult, it's Prosopoccoilus giraffa from Indonesia. These animals can be really big, and practically all of them are listed in the FAO list of edible insects. FAO is the Organization for Food and Agriculture, and they proposed to switch to insect protein instead of producing meat with cows and pigs and chicken. Because this is an alarming fact, 70% of the agricultural land worldwide is used to produce meat and feed for animals. 70%. So imagine how much we set pressure to cut down rainforests and so on just by relying only on this kind of meat production. If we would switch to insect proteins, we could produce this kind of high quality animal proteins and fats with only substrates that we cannot eat as humans, like wood or leaf material or wood chips or whatever we give them to feed. But mostly for the production of meat, we have to give to the animals staple food of humans too. That's what we should change, and that's also why we propagate this project, Food from Wood, because wood is here so abundantly. We have enough material to produce a lot of these animals. So the first stage is this nice larvae and beetles of stag beetles here on this piece of oak. He probably is very happy. Afterwards, after the stag beetle larvae have shredded up all the material, it looks a little bit like this, but it's like a sculptures made by the nice beetles here. So you see the holes where the larvae have digs through the wood pieces. Looks like eyes here, or also this little sculpture here is very nice. So that's the work of the stag beetles. And in the next step, that's also what happens in nature. Then come the rhinoceros beetles. Mostly they eat from the leftovers of the stag beetles, or they eat themselves and chew themselves on kind of leftovers of the wood blocks of the stag beetles. That's a normal progression in a cascading process of recycling wood material in nature. This one is a very nice one. It's a male Megazoma dios from Brazil. Larvae can be up to 200 grams heavy. The beetles themselves, they are around maximum 100 grams, and they're pretty big, as you can see here. In the next video you can also see here a larva, a pupa of Megazoma elephas. It's a rhinoceros beetle from Central America, and as you can see in this video, they are really big, and they contain only the material, protein, fats that they need for the development into an adult. They don't have any gut content anymore. That could pose a problem for people who don't want to eat all this woody material inside of the larva. That's a really big one, over 10 centimeters long, and this was 82 grams heavy. That's the second stage. All of these animals, they are traditionally eaten by the indigenous people in the rainforests. Of course, they are a delicacy for them if they find one. They hope more to find a larva, because pupas you hardly find. They are hidden very well inside of the wood. And the beetles, they contain a lot of thorns made of chitin, and if they come into your gut, they can harm the body, and you have to remove therefore all these spiky legs and hard material chitin that is not digestible by any animals. Nobody's also protein, of course. It's a proteinic structure, but we cannot digest it. Yeah, next stage. After the rhinoceros beetles have eaten up their part of the material, mostly inside of hollow trees, where also old leaves are blown in by the wind, or on the floor of the forest, all this half chewed up material leftovers from the rhinoceros and the stag beetles. That's the field at the end of the rose chevers. That's a larva of a rose chever from Africa, Mechynorrhino polyphemus. It's not a really big larva, but you can see the dimensions around. They can get between 30 to 50 grams a larva, but as you can see here, they contain a little sac at the end of the gut where they process the food that they eat. They don't process the food themselves. They work together here with microorganisms. The microorganisms, they break up the cellulose. They use the energy from the cellulose to fix nitrogen from the air, and then they can grow well in this gut, and the larva resorbs the microorganisms for the build-up of their own protein, because that's a real protein-rich stuff inside of this larva, and normally in a piece of wood there are not so much nitrogen. They need more that they can grow so big. What you see here, these pellets, they are not made by a little machine. They are made by the larvae themselves. They suck out all the water of the material, so you don't have to give them extra water. They just eat up the leaves and all this stuff. They take out the water that they need, and they leave these excremental pellets. And the excremental pellets are 3 times richer in nitrogen than the original feed material for the larvae. So that's a real good process of enriching the soil with nitrogen, especially in countries where nitrogen is lacked in the substrate. Let's say in developing countries. Normally in our industrialized agriculture we have too much nitrogen because we import all the food, all this nitrogen rich material in millions of tons, and we put it on our fields, and that's what makes them too much nitrogenic. And also that's the problem, it's washed out into the rivers, and so that's one of the problems. But for the developing countries it's very nice to see that we have a technique to enrich the plant material and the soil with nitrogen naturally, because in the technical aspect of producing nitrogen we need a lot of electric energy, and this would be nice to produce it on a small scale, small farm, practically anywhere. So that's the process of it. Now if we go back once again, what we can see, plants, they need the light of the sun as a source of energy. They need water and carbon dioxide. With this process they produce glucose in the photosynthesis. They invest the glucose into fruits, berries or whatever to attract animals, to help them spread the seeds of the plants and to help spread the plants in the world. Also we can eat it, of course, but we like sugar also very much. And then the plants can combine some of these glucoses in a way to produce a more storable form of energy in the form of starch, mostly used in grains as an energy reserve, or also in potatoes, like this are mostly starch. And the third material is probably the most important. They need building structure material, the plants, to reach up high into the sky, more than 100 meters, to present the leaves to the sunlight. And this material is that one, wood. It's also a combination of glucose in a spiralic form. It's very tough and strong, and it has also the advantage that animals cannot use it as feed. So it's too hard. If even they could eat it, they couldn't digest it. And the mushrooms can. So that's why we have to make these two steps. We first have to present this wooden material to mushrooms, also in the form of these wood chips. We have mushrooms, edible mushrooms, that also can eat up these chips of wood that are very common in our forest agriculture. And we can use also all the leaves that fall down from the trees, all the little twigs and so on. And with this material that is pre-processed by edible mushrooms, we can feed insects, edible insects, and have at the end an enriched, nitrogen-enriched, naturally grown, pelletized gardening soil. Yeah, some questions. Mostly they say, what is with the invasive organisms? Do they disturb the biodiversity in our place? So that is not the case with these tropical kind of animals, because in our temperate region they cannot survive. They need temperatures between 25 and 30 degrees, and as soon as it goes below 10 degrees they will die as adults and as larvae. One of the things that is interesting in our Western world is that we can use these animals in urban farming. As you can imagine, a bedroom in a two-chamber flat is not perfect ground for keeping cattle or a chicken in the bathroom or wherever. So these animals mostly are too big, but insects, they can be perfect organisms to keep in urban farms. You can keep them without light, in the garage, in a closed room somewhere. They don't smell bad. That's one of the advantages too. They always smell like the forest soil. They can be fed with material that you find everywhere, also in the cities. All these leaves material, they are collected normally, and if you can feed your urban insects with this, that would be a good idea. And also, it's for educational reasons. It's nice so that young people who are interested in urban farming show to the elder generations like me how we can easily change from eating meat from pigs and cattle and fish also to eating insects. That's also why we said not edible insects, so we say sky food. Like seafood is animals from the sea, we say sky food to edible insects, because insects have been the first animals on planet Earth that could fly. It was around 100 million years before the dinosaurs already. So that's about the project Food from Wood. We just started organizing the whole research project. Of course, we need a lot of support from people like you. Also support financially, because you know there's not a lot of funds that support edible insect project, because it's a new topic, and that's also why it's a little bit difficult to crowdfund, to fund money for this project. But we're sure that we can find somebody who supports us with reorganizing the decomposing process of wood-based plant materials. Thanks for watching.